is Jeshuah Gilroy, and welcome to my Holland College research project entitled Assessing a Bacterial Consortium's Potential for Bioremediation of Quinoline. Now, let me introduce you to quinoline. Quinoline is a chemical produced in many industries. It's present in petroleum. It's a byproduct of when coal is transformed into steel. It's also a wood preservative. It's used in paints, some dyes, and is a polyaromatic hydrocarbon derivative. Polyaromatic hydrocarbons being a class of molecules that have been known to be extremely toxic to humans and the environment. Just ask the Sydney tar ponds. And quinoline is no exception, having been shown to cause genetic mutations by the formation of diols in dogs, which we love, in rats, and in mice. So it's been shown to be a carcinogen, which is very toxic and mobile in water. Now, how are we going to break it down? Well, the bioremediation part should give you the hint. We're going to be using microorganisms, specifically veterans of quinoline degradation, such as Pseudomonas putida. Pseudomonas putida, a very resilient organism, has been shown to be able to degrade high levels of quinoline, some strains over 200 times 10 milligrams per liter of quinoline. And some species have actually degraded 200 milligrams per liter of quinoline within 3 hours. Bacillus subtilis has also been shown to be able to degrade 200 milligrams per liter of quinoline in approximately 65 hours when not immobilized. And we're going to be testing if these two together work well, because who wouldn't want two of something? Yeah. Okay, scratch that. Not in every case. But we wanted to look at the synergetic or non-synergetic effects that they might have, as there's a lot of differing opinions in the scientific literature, where some have said Pseudomonas putida and Bacillus subtilis being co-cultured together so often indicates that they do have benefits to each other's growth, while others say that they actually are competing. In fact, it's been shown before that when there's a source of carbon such as glucose, studies have found that since it's easy to break down, that the two bacteria would actually compete and attack each other, but they work together with more complex carbon sources. Now, others have stated that such studies, since they're only looking at the two bacteria together, don't actually account for the broad range of activity that those bacteria have on each other when they're interacting with even more organisms. So in a small sample set with only two bacteria, it may look like it's a bad thing, but it might actually be a good thing when you have a lot. Now, let's just get down to what we did in the methods.
Pseudomonas putida and Bacillus subtilis ATCC 6633 cultured on LB agar with 2 grams per liter glucose and incubated for 22 hours at 30 degrees Celsius. 4 weeks following initial incubation were inoculated into 20 ml LB broths incubated overnight and then transferred into 50 ml of LB broth containing 2 grams per liter glucose and 200 milligrams per liter quinoline.
In triplicate, we had the no bacteria group,
Pseudomonas putida by itself, Bacillus subtilis subspecies spizizeni by itself, and both bacteria together. And they were analyzed at time 0, 1 hour, and 68 hours after inoculation.
And ran those on a UPLC, took the peak areas against an 8-point standard curve, and ran a two-way repeated measures ANOVA, where a Tukey's multiple comparison post hoc was run. We normalized the data by dividing the means of the peak areas by their time 0 counterparts and compared them. What we found was there was a significant amount of breakdown under all three consortiums, but no significant difference between the consortiums. But interestingly enough, the Bacillus subtilis one did have lower, though not significantly, but interestingly lower amounts of remaining quinoline compared to the co-culture, which may indicate that it was actually being outcompeted by the Pseudomonas putida, especially in the presence of glucose. Future studies should definitely look into applying more bacterial groups removing the LB broth with like methanol, transferring the quinoline over in order to remove interferences, and assessing higher concentration of quinoline and assessing time points that are shorter, as well as less favorable conditions and conditions that more closely favor wastewater effluent and the like. However, we did find breakdown in a species never shown for breakdown before, so that was very interesting. And I just want to thank everyone in the bioscience technology program, especially Dr. Jessica Livingston, Dr. Michael Gibson, Marla McKenzie, Chris Mafaden, and all my wonderful classmates for their help. Have a great day.